Okay, so we're going to be doing Lab 13 here, which is a little bit like what we were doing last week, but a little bit different here. So we're going to be using position registers, but the big difference is we're going to use the position registers as actual points, position points for our instructions instead of using offsets. Okay. And I also want to kind of review indirect addressing. We talked about it a little bit there right before spring break, but we're going to kind of go in and practice a little bit with those also. So the lab is pretty much kind of like what last week's lab was. We're going to, walk through the various exercises and then create a couple. There's actually going to be 3 different teach-dependent programs. One's going to be a macro. But then once you create those, you want to add those to the zip file and attach those and upload those here. So, you click over here on this Lab 13 and come over here and attach your zip file at the end. Okay. All right, so looking at the lab, okay, this is the instruction sheet for the lab. And as I said, we're going to work with position registers. We're going to do some indirect addressing, and of course, along with all that goes looping and branching. So there's some more practice with looping and branching there. Okay. And so what we're going to be doing is we're going to be starting off with last week's lab where we had the offsets. And so if you remember what we ended up doing in last week's lab, if we look over here at this picture, zoom in on the picture a little bit. Okay, so if we look at this, this is just the brown box piece that I put here, but we had the brown box, and of course the brown box has its 4 corners, which I've labeled point 1, 2, 3, and 4 for illustrations within the lab. And then what we did was we put in these smaller fixtures or rectangles or boxes, whatever you want to call them here. The software calls them fixtures. And we kind of embedded these other fixtures inside of here. And so if you remember, in the X and the Y directions, each box was 50 millimeters in from the associated corner of the main box. And then it was also 20 millimeters taller than the original box. Okay, so each time we go in 50 millimeters in the X and the Y, and then we go up 20 millimeters, and we just we were using offsets to go around. So we went around the brown box, the outer box, then we went up 20 and in 50 to go around the next box, and then in 50 X and Y, and up 20 in the Z again to go around the green box and the blue box, and then we repeated that with the red box. Only the red box we were using the tool frame, and for the brown box we were using the user frame. Well, today we're just going to be using the position registers as the points themselves. And so we don't have the tool frame is always there and always a critical part, but we don't have the tool frame offset. We're not going to use any offsets at all. We're just going to adjust the position registers. But to do the when you do just position registers, you're effectively adjusting in the user frame, not in the tool frame. Okay, and so we'll what we're going to do then is we're going to kind of go around, around the brown box here, which is 0.1, 0.2, 0.3, 0.4, and then back to 0.1. And then point 1 over here is where the red box starts. So if you remember up over here, where point 1 is, that's where this the red box is going to start. So you should actually only end up, we're going to go around the brown box, and then we're going to go around the red box. And when you do that, you're only going to have 7 points there, because point 1 is the corner point for both the red box and the blue and this brown box. And so you just have point 1, which is for both boxes, and then point 2, 3, and 4 on the brown box, and then points 5, 6, and 7, and then returning back to point 1 in the red box. Now, if you want, as I talked in class, you can also have an extra point up here in the safe area called like a home point, and that's fine. Okay, I'm just not including that in the lab. But if you want to put that, I certainly support that, because I always like to truly start any program up in this kind of safe area where you know you're not near anything. And so you start the program there, and then you're going to come down to what I've got labeled as point 1 as your corner point where the 2 boxes meet as the start point. And we're going to go around the brown box, and then immediately after returning back to point 1 of the brown box, then you're going to go around the red box. Okay, and I didn't really state clockwise or counterclockwise in this lab, but the idea is to basically copy the programs we had before. Okay, so whatever direction they were going, I believe, if I remember right, this brown box, we went around it clockwise, and then we went around the red box, we went around counterclockwise. All right, so what we need to do then to start off is we're going to take and open our week 12. And the first thing you want to do then, as soon as it opens, is immediately go through and do a save as, and save it as a new project, save it as a new work cell, so that we can, if we make any mistakes in here, for one thing, if we decide, well, really don't like what I did here, and I just want to start again, then you can just go back to the lab week 12 and kind of restart the lab starting at that point again. All right, so once we do that, then what we're going to do is we're going to create a position register program called LF position register. And remember, LF is your last name, first name. I don't know if I mentioned that in the lab, but I assume you guys know that by now. And so we're going to start off with this program, and we're going to start by just simply copying our brown program that went around the box. Okay. And then now that program just went linearly, so it went to point 1. Okay, originally, like, I had joints in mind, so I really want this to be linear. So you have to, if you have it in joints, you need to change the motion type to linear. But so we're going to move to point 1. Okay, and again, there's point 1 at the top left of the box there. That's point 1. We're just going to move around the box. So we're going to copy this brown box program over to this new program called LF position register. And we're going to just make sure it goes around the box. And one thing, I've kind of said this before, but I think it bears repeating, is when you do this, you want to make sure that you do small steps in a program and then test those steps. So rather than try to write the entire program and hope the thing works and not have to make any changes, you really want to just do a little bit and make sure that part works. That way, if something's not quite the way you want it, you know exactly where you need to go to make the changes before adding more. Okay. So I guess I don't have my teach pennant open here. So I'll come over here. I'm going to open up my teach pennant. All right, and I'm going to, right now, I've got my shapes program here, which starts at a home position up here above the box, and then goes around the brown box. So I'm just going to test this program. I know I said in the lab to use the brown program, but my brown program on here is not working, so I'm going to use this one. So, but I'm going to test it first and just make sure it does do what I want it to do. Okay. All right, so what it's going to do here, right? It comes down and it just goes around the brown box, moving from point to point in a straight line. Okay, so I'm just in every corner of the box there, and then I'm returning to a home position here. So in this case, I've got this home position. Position number 1 in this program is the home position up above, and so position 2 is actually what I had labeled in the lab as position 1. Your numbers may be different, because remember that your program might have if you like added some lines or added some points and deleted some points or whatever, your numbers may get kind of messed up. I don't care what the numbers are. I just want you to know what those points are. Okay. All right. So here's the main program. We went around and we're going around the box. So that's kind of the start of our program. Then what we're going to do is we're going to copy the red box program into this. So right here at line 6, where it returns back, okay, so where it returns back to point, what's labeled here is point to the origin, where the two boxes meet. All right, that's where you're going to paste in the code to go around the red box. Okay. Now for this lecture here, I'm going to leave that part out, but that's the part you'll have to add in here. All right, and then we're going to return. But so now, though, what we need to do is we need to move to the next inside box. Okay, so we're going to have to move into the inside box on there, but we're going to use position registers to do this. So the first thing we need to do is take these position points, point 2 here and this, point 3, point 4, and point 5, these 4 corners of the box, we need to store these inside of position registers. Okay, so, and I'm going to overwrite line 7, which is returning home, because that really should be way at the end of the program. Or I could overwrite it, or better yet, I'm going to come over here to insert, and I'm just going to insert like 10 lines. I might need more later, but that way I'll keep that home one sitting in there. So I'm going to come here, select insert, and I'm just going to say, give me 10 lines for now. Okay. And so then I'm going to go to instruction. And what I'm going to do is I'm going to take point 1 and store it inside of a position register. So I'm going to select register equals, but then come down to position register. So position register number 1, okay, which is this origin piece. I'm going to set that equal to point 2, which is the point where I'm currently at right now, okay, which is where these two meet. All right, so now I've got this, but I also need it for point, the 3rd point over here, and the 4th point, and the 5th point, okay? So I need to repeat this. You can repeat it a couple of different ways. Honestly, if I come down here and I just go to instruction, I got to select instruction, then I got to select register equals position register, put in the number, and then point, and then put in the number, okay? And so I can do it that way, or we can make use of copy. So I can come over here, I can do a copy and press copy. I just want to copy 1 line, and then I'm going to paste it. Now, when you paste it, since it's not a motion instruction, you can paste it using any method you want. Okay, just come over here. See, it doesn't matter whether I paste with logic or paste with position, because all I'm doing is changing that. But see, now I can just come in here and change my numbers. So 4 goes into 3 and 5 goes into 4. All right, so I've got my position registers 1, 2, 3, and 4, which are going to move around the brown box. Okay, only I'm going to shift them. Okay. So now I also need to create a few registers. Okay, so I'm going to come back to instruction, register equals, and so I'm going to have register number 1 here, which I've actually already labeled, and that is going to be equal to a constant of 50, which means 50 millimeters. Okay, so this is register 1 I'm going to use for my offsets. So remember in the XY direction. So remember it's a 50 millimeters in both the X and the Y direction. So I'm just going to set 50 here. And as you can see, I've already pre-labeled this register to say X and Y offsets, so I can remember what that is. Now also remember, while we're talking about this labeling of points and stuff, if you come over to the line numbers, you go to edit commands and you come over to 7 comment. If I set that comment off, then all these labelings disappear. Okay, but if I come back here to this comment, then those labels pop back up. Okay, so just a reminder of what those labels there do. All right, so so that's register 1. So now I'm going to add another instruction, which is going to be another register, which is going to be register number 2. And register number 2 is going to be the Z direction, which again I've already labeled, which is going to be going up. All right, and so that's going to be in the 20. And now I need a counter, because we have four boxes, the outside box, and then we have 3 inside. Okay, so I'm going to need a counter to count going through those boxes. So I'm going to insert I'm going to add an instruction here for another register, which is just going to initialize my counter. Okay, and so I actually called this box counter. Okay, so register number 3 is a box counter, and I'm just going to start it off at 1, which actually means the internal box. Okay, because we've already went around the brown box. The lines up above here, starting at line 6 and above, it went around the brown box. Okay, so now I'm going to create a label so I can loop around. So when I go into the yellow box, the green box, and the blue box, I can loop, and I only need the code once for those. All right, and so I'm going to go to instruction, label 1. And again, if you want to, you can label these. Come over here, hit enter. If you're using the newer iPendant style thing, you can select a keyboard to type this in. And so this is going to be loop through the inner boxes. Okay. Well, yeah, I didn't think it was all going to display there, so it didn't all quite display. So you might want to loop through I just put boxes there because you can't put too much, make it too long. All right, so now, before I go too far, I guess what I'm going to do here is just add in the position line. So I actually have 4 blank lines here. I'm going to leave a couple of these blank maybe, or well, I'm just going to come over here just in one of these blank lines, and I'm going to add a motion instruction. Okay, so I'm going to come back to my point, and I'm going to add a point here. Okay, and I want this to be a linear movement, so I'm going to come up here and go to choice, make this linear. But right here now I'm at 0.6, and I want this to be 0.6. This is a position register, so I'm going to go to choice again, and now under choice I'm going to choose PR. Okay, so this is my position register that I've already assigned up above. So I'm going to have position register 1, and I'm going to move to position register 1. And now I'm going to copy this. So I'm going to come over here. I'm going to go next, edit command, copy. I'm just going to copy this one line. So I press copy again for one line, and I'm going to paste it. Okay, and when I paste it here, I'm going to paste, again, it doesn't matter too much here because I'm not using actual points. And so I'm just going to paste logic, paste logic. So there's my 4 points of the brown box again. All right, and so I'm just going to come around here, and this is point 1, position register 1, position register 2, position register 3, position register 4, and actually I guess I need one more because I got to return back. So I'm going to return to paste, and I want to return back to the corner I started at, which is position register 1 again. Okay, so now I'm going to loop around there, and then right here on line 21 now I'm going to go instruction, and I'm going to advance my counter. So I'm going to go to register, but I'm going to choose the plus option, and I'm going to have register number 1, or no, it wasn't 1, it was register 3 as my counter. Okay, register 3, we're going to go to a register 3. And we're going to add 1 to it. And so this is going to advance my counter because I have to go through, I've already done the brown box, but now inside the loop, I've got to do this yellowish box. Actually, it looks almost more like a cream color here, but I kind of labeled it yellow in the previous lab. So yellow, green, and blue. And so now I advanced this counter, and then I'm going to add one more instruction, which is going to be an if statement that's going to say if it's less than 3. So if register 3, which is my box counter, is less than 3, I'm going to jump back up to label 1. Okay, so what this is going to do now is this is going to walk around the brown box 4 times. So let's just test that before we go any further. So I just come over here, I'll hit forward. Okay, and I changed lines, so it's asking me if I really want to do that. And actually the answer is no, because I want to start at the beginning of the program. I'm going to come back to the beginning of the program and start again. Okay, and so now I'm just going to say yes and restart the whole program. So it comes down, it goes around the box once. All right, now when it first went around the boxes, it was in the points. It was going around the points, 0.2, 0.3, 0.4, and 0.5. But now you see that I'm inside the loop, and I'm looping around. Line 14 begins the loop, right? And line 22 finishes the loop. So it's looping around, but it's using the position registers. Okay, but I haven't changed the values of the position registers. So it's simply going around. Oh, good catch. Thank you, Clint. This should have been a choice constant. Yeah, I didn't even catch that. I hit that. And then the constant should be less than 3. Okay. Yeah, thank you. That's yeah, so I hit that error message there because of that. I didn't catch that. Thank you. All right. So I'm glad to see not everybody's asleep too. So all right. So I have to hit reset here because I had the error. And so now it's just running through, and then it returns home at the very end, right? So point 1 was home. So again, if I run this through here, the first time around the box, it's running through actual position points, point 1, point 2, point 3, all right? And then once it gets done with that, it's going to take and store point 2, 3, 4, and 5 into position registers. So those are lines 7, 8, 9, and 10. Now it's going to flip through those really, really fast because it doesn't have to move the arm, right? So this is just computer code executing, shifting the numbers, those positional points, X, Y, Z, yaw, pitch, and roll into the position register memory location. And so that happens, you know, within like a microsecond or a couple microseconds. It's very, very, very fast. And so it'll flip through 7, 8, and 9. It'll be through those in a heartbeat. Okay. So if I just hit forward and allow it to continue, it gets there, back point 2, back to the origin. And then it starts moving through. I mean, like I say, it's those lines 7 through 10, they just whip through there in the blink of an eye because it was just a computer instruction moving ones and zeros inside of the controller into a different location. Okay, so that's why those went through so fast. And then now we're in the motion instructions, but with the position registers. And so we're just going around this 4 times. And so after, or well, 3 more times. So we went around once using the points, and then a second, a third, and a 4th time, but the 3rd, 4th, and 5th times was using the position registers. Okay. All right. So now, you know, again, it's good to just test this and make sure that we didn't kind of mess up and it starts going off in some weird direction or anything. And now we're going to start adding in the offsets. Okay. So when you look here, you see that like 0.2 and 0.5 they both need a plus X direction, or excuse me, a minus X. They need to be shifted in the minus X. But 0.3 and 0.4 need to be moved in a plus X. So 2 and 5 are minus X, and 3 and 4 are plus X. But remember, these are position registers, so my numbers are off, I guess, because this is position register 1 and 4 and position register 2 and 3. So what we're going to have to do here is insert some more lines right here before we start executing the position register motion instructions. I'm going to come over here next, edit, insert, and I'm going to leave one blank line so that I remember where I need to come back to. Okay, or I could put a remark in there or something, but I'll just leave it blank for now. And so I'm going to come in here and I'm going to select insert 4 lines. Okay, and what I'm going to do on these 4 lines then is I'm going to move the X I'm not going to touch Y or Z at the moment, but I'm going to move the X. So I'm going to go to instruction, register. Okay, and I need to add for 2 and 3 and subtract for 1 and 5. So I guess I'll do 1 and 5 first. So I'm going to subtract. Now notice here what I'm subtracting. I'm selecting number 3, which has the I and the J in there. Okay, and so when I'm subtracting here, I'm going to have position register 1 in the X direction. Okay, and what I'm going to need to do is I need that same, I need that same choice again. So we need to come all the way over here to the 3rd screen and choose this PRI, J again. All right, and so it's still position register 1, still in the X direction. But now we're going to select the register. Remember, we've created a register for this. It was register number 1. Okay. And I don't know, I inserted all those lines, but now that I think about it, it's probably easier to copy this line and paste it. So I'm going to copy it. And then I'm going to paste it. And I'm going to go ahead and just paste it 2 more times. Okay. And so when I paste it now, I'm going to come over here. This is going to be position register number 2. Position register number 2. But remember, position register number 2 needs to be a plus. So I'm going to come to the minus sign and I'm going to select choice and change it to a plus instead of a minus. Okay. So when I did 2, it needed to be a plus. And then I'm going to do 3. And 3 again, make sure that you get it in both spots. And 3 was also a plus. So I'm going to choose, I just hit my mic again. On this laptop, when I hit F4, because this choice should be F4, it should work on your keyboard also, but on this laptop, it mutes my mic. So hopefully you guys can still hear me because I hit it again. All right, so 4 should be a negative, so that's okay. But this is 3, so yeah. Okay, thanks, Matt. Yeah, so then choice, this is number 3, so we need a plus. And then I'm going to go to the next one, which is 4. And that should be a 4. And 1 and 4 are negatives. Okay, in the X direction, 1 and 4 are negatives. And so I've got minus, plus, plus, minus. And I got them in order. I think it's probably a better idea to put them in numeric order, 1, 2, 3, 4, instead of putting in the order of pluses and minuses. But, you know, that's up to you. As long as you get your logic correct, it should work. All right, now that's a lot of code right there. So before I go any further, I'm not going to touch the Y's yet or the Z's. I'm just going to do that and test this. So I'm just going to come over here and I'm going to do shift. Well, I'll come back to the beginning of the program, I guess. I always like to start at the very beginning. So I'm going to come back here, start, and walk through the entire program. It's going around the brown box. Okay. And now it's going around the yellow box. But the Y's are messed up, but the X's are okay. All right. Now, did it go around? Actually, it didn't go around the blue box, did it? I'm missing one. Yeah, absolutely. So what I need to do here is I need to do one of 2 things. I forgot. Normally, I start a counter equals 0, but I started my counter at 1. So I could do one of 2 things. I could change this to a 4, or I could change it back to a 3, and go to choice. And when I go to choice, I could say less than or equal to 3. Okay. you know, whatever makes you happy there. Just, but yeah, see, I missed that, I guess, while I was talking when I was testing it before, that it didn't go around as many times as it should have. It was one short. Okay, so now we're at the yellow box. Okay, and the green box. And now we're at the blue box, but only in the X's, right? Our Y's are still messed up. Any questions about that? Do you see the difference here where we're not using offsets? I mean, honestly, you guys should have been doing this exact same modifications last week when you did the offsets. The only difference is I'm modifying them as actual points instead of using them as offsets. So I didn't zero them out. They're not zero. Okay. If we go look at our data, go to position register and choose these position registers and look at these positions, these things aren't zeros. Okay. The X and the yaw are not zero. Okay. And if I look at the next point, right, the X is a completely different X. And if I look at the next point, the Y's are different. Right. So there I've got a different X and a different Y. Right. So that's really the big difference that we're doing here, is we're just using these position registers inside the as the position points, but we're shifting them instead of using offsets. Okay. Sometimes it's more convenient to use offsets. Sometimes it's more convenient to just modify the point itself. It just depends on kind of what your needs are and things like that. Like if you're palletizing, a lot of times, like if you're stacking a pallet or something, you probably don't want to, I mean, you could use offsets, but it's probably just as easy to modify the position register. Okay. All right, so now I've got these four instructions here, which we're adjusting the X, right? So all these we're modifying the X. So now what I'm going to do is I'm going to copy these 4 lines. So I'm going to come over here to copy, and I'm going to copy these 4 lines. So I'm going to press copy, arrow down, and get all 4 lines. Oops, I'm on the label. Let me get down here, start it again. So I need to be on 15, which starts the position register. Copy, and copy all 4 of these lines. And then I'm going to come down here. I'm going to leave a blank line just to keep them separated. And then I'm going to paste them. Okay. And again, since there's no actual motion instruction, it doesn't matter which paste you use. But I'm going to paste these in here. Now, I should put a remark here so I can keep track of what's going on. So if we go back, previous, go back to instruction, I'm going to go to miscellaneous, and under miscellaneous, I'm going to put in a remark. And I'm just going to remark, I should have done this before, but as this gets kind of confusing with all these instructions, so I'm going to come over here and I'm going to go ahead and label this, and this is shift in the Y direction. I'll just say Y dir because I'm going to run out of room. Okay, so I'm shifting in the Y direction. Then I'm going to come over here. I should have done this before. I'm going to insert a line. Remember, the quick way, if you only need 1 line, you come to insert and just hit enter twice, and that'll get you 1 line real quick. You don't have to go down and press the number 1 and then hit enter. You can just hit enter a second time. And I'm going to come back to miscellaneous and number 5, remark. And I'm just going to come over here and label that. And this is one place where the software is so much nicer to label because I can just use the keyboard. Shift and X direction. Okay. Now, actually, let me remind you, with a real teach pendant, you can plug a USB keyboard into it, and then you can type, so you could have a keyboard typing there, even if you were working on the real robot. If you have one of the newer eye pendants, you could plug in a USB keyboard or a USB wireless dongle sort of keyboard into it. And then you could use the keyboard option to add these labels and stuff, which just make it so much nicer than trying to go through the other method where you have to come in here and press. If you want the letter F, you got to press it 6 times and things like that. Okay. All right. So anyhow, so we're going to come back to the Y direction. Now remember, the Y direction is also still in the direction of 50 millimeters, or the amount of 50 millimeters. Okay. And I've got points 1, 2, 3, and 4 here, but I've got to change. This is in Y now. So I got to change this number here to be a 2. So I have to press in 2. And I got to do that for each one of these. I got to come in here and put in a 2. Okay, so I put in a 2 for each of those. But the other thing is my pluses and minuses aren't quite correct. All right, so plus Y is going from where the pointer is now down toward the bottom of the screen. Right, so if you watch as I move the teach pendant, right, this is in the plus Y direction. Okay, so points, now we've got position register 1 and position register 2, which are associated with points 2 and 3. Those need to go in the plus Y, but position register 3 and 4 need to be minus Y. So this one here, the first one, should be a plus. So I'm going to go to choice and choose the plus. So the 1 and the 2 are pluses, but the 3 and the 4 need to be minuses now. So I'm going to go 3 and 4 need to be minus. 4 already was a minus, so I just have to change the 3. Okay. All right. So now, once again here, I'm going to come over and I'm going to kind of use the item button to get to line number 1 and jump back up to line number 1 using my item button here for a change. It's much faster than arrowing up through all those lines of code. And I'm just going to hit forward and test this again. Okay, so remember, we haven't done the Z. So it's actually going through, so the pointer is actually sticking into the box right now, which of course, would be destroying it if we had it real boxes, but since they're virtual, we can do this with no problem. Okay, so that looked pretty good. Okay. All right, so any questions about this so far? Quite a bit of stuff here, but really we've talked about this all before. All right, so the next thing we need to do is we need to go up in the Z direction. All right, so but looking at the lab instructions, I don't know if you guys have opened them yet or not. I want you to use a macro to go up in there. So we're going to create a separate program called go up, which we're going to make a macro. All right, so we need to come back to our select. All right, And so I'm going to come back to select, and I'm going to create a brand new program, which I'm just going to call go_up. Okay. And I'm going to start off with here, I'm just going to add an instruction. Okay. So now notice this macro is not going to move anything. Okay. But what it's going to do is it's going to go up. And so we need to use a register. And in our register, we're going to add in the Z direction. So we're going to come again to this PRI, J. And I'm just going to add for position register 4 right now. I'm going to come back and modify this later. But I'm going to position register 4, the Z direction, which is number 3. Okay, and then again, we got to come back over here, which on the second time, it's way over here on the third screen, number 4, to choose the PRIJ. And again, I'm moving 4 right now. I'm just going to move 4, which the reason I'm choosing 4 is we can see it on the screen. We can see point 4 down here on the screen best. Okay. I forgot when you shake your window, it hides your other screens. Let me pop up my browser here too. Okay, so now number 3, and remember that we've already set a register for that, so it was register number 2, which was our Z offset. So this macro is not going to move the robot at all. All it's going to do is add 20 millimeters to the Z position of position register number 4. Okay. So if we go back to select, go to next and select detail, remember the group mask here? I could come over here and tell this it's not allowed to move. Honestly, I don't think it gains you anything. Okay. Because I'm not planning on tying this macro to one of my user keys down here. So changing this, even though it's not moving the robot, that's true, but changing it to a star, since I'm not trying to tie it to one of those user keys, I don't think it really matters. So you can do that if you feel like it, because you know it's not going to move it, but you don't have to. Remember, we could select here, we could go to choice, and we could choose to define it as a macro. I'm going to leave that off right now because I just want to remind you of something else. You can, since we're going to make it a macro, I'm going to come over to my menu screen. I'm going to go to set up macros, and I'm going to come down here and I'm going to just label this. Actually, I'll label it right here on the first. So it's going to be here at the top. So what I'm going to do here is right here at the top. Now, actually, before I do that, let me double check here. I go to select, detail, subtype is none. So this thing is not a macro, okay? I've not made it a macro, but what I'm going to do is I'm going to add it to this screen. And so I'm going to come over here and I'm going to give this a name. And I'm going to expand the name a little bit here. This is like go up in Z direction. Okay, so there's the name of my macro instruction name. And then we're going to come over to program. And under program, I'm going to go to choice. And I'm going to select through here till I find it. Now it's go up and it's on manual functions 1. Okay, and I'm not gonna change that. That's just manual functions 1. I'm gonna hit enter. And I'm gonna go back to my select screen and I'm going to hit detail, and now notice the subtype is a macro. So this is just kind of a reminder. You can come over here, you can choose macro there, or if you add it anywhere to anything under the setup macro and you add it in here anywhere, it's going to automatically label it as a macro. Either way is fine. All right, so then the other thing though we're going to do is I just want to show you right now, if I hit menu and go to manual functions, there's that macro go up in Z direction right there at the top of the list. Okay, honestly, I don't need it on this screen, so I didn't have to do that. That was just to remind you how you can set them up there. But for this lab, we're not going to use this manual macro screen. We're not going to use the buttons down here or anything. We're just going to call it. Okay, but see, by naming it here, go up in the Z direction. When I come back to my main program, which I guess I forgot to change the name of my program, okay? But when I come back to my main program here, what I'm going to do here is down here on line 26 of the main program, I'm going to call the macro. Now, I could call the macro using a call. So if we come over here and did a call, I could call the program go up, okay? I could call the program call up, and if I do this, it doesn't matter whether I declared it as a macro or not. It's just any old teach pennant program, okay? Or I could come to instruction, and under instruction, I can go over here to number 2 and choose macro, and now I can choose it with the longer name. So I can either call it using a call and call the actual teach pendant name go up, or I can simply call the macro name. Either one's perfectly fine, okay? But I don't want to do both, okay? So I'm going to delete this one here, okay? Because you only need to go up once each time around the loop, okay? So now I'm going to go up in the Z direction, but only for point number 4, okay? And so I'm going to go ahead, hit item, go to the beginning of my program, item 1, enter, and I'm going to hit forward, and I'm just going to walk through this program one more time. So notice it goes all the way around the brown box, starts going around the yellow, but notice up here in the yellow, it's actually going up. Okay. But it only did it over here on this lower corner. All right, it only did it over here at this lower corner. So let's just watch out one more time. Okay, so now we're going around the yellow box, and we come up to that. We're in the green box, we're coming up to that, and then we're in the blue box, and we're coming up to that. Okay, so that went around that one. It raised. So, you know, when we come down here and we call the macro, this is in the main program, we're calling the macro. Here's the macro call, go up in the Z direction, but it only moved up this bottom corner. All right, this corner over here, which is labeled 0.5 or its position register number 4, because that's all that program did. So now if I come back, I'm going to select my go up macro, and I'm going to insert 2 lines at the top of this. Okay, and so insert. And so the first line, I'm going to start a counter. Okay, so I'm going to go to instruction, registers, and I'm just going to initialize register number 4, which is a counter. actually, I'm going to initialize it to 1. Okay, so notice I labeled this, this is my counter inside the macro. Okay. And so I've labeled that counter. Okay, I'm looking at the lab right now and I'm seeing that I need to make a 5. I need to have a 5 in there somewhere. I use this counter twice, which is bad. Okay, so this is my inside the macro counter, which is I'll use that. But for the next part of the lab, I'm going to have to use counter 5. So I'll show you that. But so I'm going to initialize this counter to be 1. Then I'm going to add a label. Now labels are unique inside each program, so I can use label 1 again. That's perfectly fine. And then here, what I'm going to do, notice down here now when I come over here to position register and I come over to the number, it gives me a choice of direct or indirect. And so what I'm going to do here is I'm going to choose indirect and I'm going to use register number 4. Okay. So I'm going to do this indirect and use register number 4, and then I'll come over to this other one and use indirect register number 4 again. Okay. And so now what it's going to do is it's going to count and walk through position register 1, position register 2, position register 3, and it's going to walk through each one of those and advance those. All right. And so hopefully, Austin, you'll see the answer to your question here because we're advancing the position registers and we're adding to the position register value every time. Okay. That's why we need a counter inside. This counter is completely separate from the counter in the other program. Okay. And so now I need to increase my counter. So I'm going to come over to register and add. Okay. So we're going to have register 4 and register 4 plus a constant of 1. Okay. And then I'm going to say if my register instruction, if my register, if I need an if first. I'm saying it, but I didn't select the if. If register 4 is less than a constant of 5, then I'm going to jump back to label 1. Okay. And what this is going to do is this is going to walk through position register 1 and add 20 millimeters to it. Position register 2, add 20 millimeters. Position register 3, add 20 millimeters. Position register 4, add 20 millimeters. So it's going to do all 4 registers and walk them up. Okay. And so now if I come back to my main program, and I walk through this, it should walk through and go move automatically. It moves up to the corner of all 4 of these points here. Okay. So it's moving up and doing each one of those. Okay. So let's watch that again. We come down, we're running alongside the edge of the brown. Then we go up and we're running along the top edge of the yellow. And we're up, we're running along the top edge of the green. And then we're up and we're running along the top edge of the blue. Okay. So I'm using the counter to go up and process all of these registers at the same time. All right. So just to kind of give you what this loop is doing here, is basically, let me actually put this in remarks, so I'll leave it in here. Okay, so oh, sorry, remark. All right, so okay, so what this is doing is this is like doing PR bracket 1, comma 3. I don't know if it'll fit on here. Hopefully, it looks like it's going to fit. Options, keyboard. I'm just trying to show you this is what this code up here is doing. All right, so these lines up here, 1 through 5, are doing a loop. So I have a loop, and I initialize my counter to be 1, and then I do the label, and then I'm doing this again, this is called indirect addressing here, where I'm using a register value instead of just hard coding the number 1. All right, and so lines 1 through 5 are doing what these lines 7, 8, 9, and 10. So I could have just put these 4 lines here. I could have just said, okay, here's line 7, which is going to take and add 20 to the Z direction of position register 1. Line 8 is adding 20 to the Z position of register 2, 3, and 4. And I'm sure you guys are there, why? Why do we do this looping up here? Well, in this case, I only have 4 points that I need to shift. And so I could have just hard coded them. It was probably faster and to do that. However, what if you had 40 instead of 4? Then you would have to go through here and you'd have to put 40 of these lines, where these 5 lines that I have would have worked for all 5 lines, or all 40. I could have 40 position registers, and these same 5 lines could do all 40 of them simultaneously. Okay. And so, yeah, you're looking at this, and I got 5 lines to do what I did in 4 lines. Okay. But if I had more points, if I was like doing a star or something, I end up having 8, 10, 12, 20, whatever you're trying to do, and you have lots and lots of points or something that you have to shift, this indirect addressing will actually save you a lot of time and a lot of code. Okay. So, so it's important that you kind of understand this indirect addressing. All right, so if we just kind of come back here and come back to our main program, then it should walk around, right, and hit all those points. All those top corners of those. Okay, so now we shift in to do the yellow, shift in to do the green, shift in to do the blue, and go all around, and then just it's returning back to the home position there then. All right, so any questions about this? Piece of cake, right? I just did the whole lab. I did this part of the lab for you. Okay. So the only other thing that you have to do is you also have to do the red box. But once you got your numbers, um, it's just a repeat to do the extra points on the red box. Actually, I take it back though. When you do the red, you're going to have to use 8 position registers because we just changed position register number 1. Okay, we've changed position register number 1 to move up this way. And if you're also trying to do the red box, you need to be shifting it this way. So you will need 8 position registers. Okay. So you're going to start off that position register 1 and position register 5, I guess, are exactly the same when they start off. But as you start shifting up, as you start shifting up there, they are going to, when you come over here and you hit these other boxes, okay, this will have to have a position register 5 to move up these corners. So you will need 8 position registers. I wasn't thinking about that. All right, so that's pretty much the first exercise of the lab. Okay, the second one is in some ways shorter. If we look at this second part of the lab, what we're going to do is we're going to use a joint position. And we're going to return home. Okay. So, and I'm not going to do that whole thing for you because I pretty much did this whole other one, but I'll at least give you a start on this. So when we look at a point, okay, so if you come over here to any point, remember that there's this configuration piece. Okay, so we have this configuration, which means like not flipped, the arm is up, and top or bottom. So you have this configuration piece over here. Now this joint, when you look at, if you just kind of come over here, grab the teach pendant, and you start shifting this thing around. Oh, I moved a point. I didn't want to do that. I've lost my point 1. Okay. Let me just jog the robot a little bit here. All right, so, so if you just kind of like grab this guy and let me zoom out a little bit. I'm just going to kind of rotate this guy some. There we go. All right. So when you have the robot here in some crazy position, okay, and see some of these joints are just kind of just like all flipped up and all kinds of different things like this, okay? and you want to get it back to the home position, right? If we come over and we look at our current position and we look at the configuration, okay, I guess it's still saying nuts. I haven't changed it that much, but I can't even get there. Okay. All right. So like right now, I don't know, I can't get to this point here, but when you look at this, you see these joints are all over the place. Okay, so like joint 1 is kind of small, it's only 4 degrees. Joint 4 is 90 degrees. Joint 5 is minus 120 degrees. And so what I want you to do is create a program to get it to go back home, where all the joints are 0. And the problem is that, you know, you might kind of say, well, wait a minute, if you come over to data, let's say I wanted to just come over here. So I'll come over here to say position register number 7 and record my current position. All right, but now I'm going to go in here and I'm just going to change these all to zeros. Okay, so I'm just going to punch in zeros here and I want it to return to the master. Okay, and so I'm going to say done here and I'm going to move to that position. Notice I'm getting a limit error. Okay, it's telling me it can't get there. And you tend to get this a lot, especially on the real robots. A lot of times I see it, the robot does a move in the software, but I know on the real robot, when you try to do that, you're going to get either a limit error or a singularity error or something because it's trying to move some way where it can't. And so what I've come up with here is this thing. We're going to create a brand new program called Go Home. And so the idea here is that this program now is going to take its current position wherever it's at. Okay, so we're going to take its current position. So how do we do that? Well, we're going to use the instruction registers equals position register, use number 7 or whatever, and I'm going to set it to JPause. JPause is the current position of the robot in joint angle. So if we come look at this now, remember that under data, okay, under position register, I set it all to zeros. However, if I come over and actually edit this program or run this program, so if I just hit forward, it'll run this line. Okay, it runs this line and gets the current position. And then when I look at the data now, see the position is just all these crazy angles. All right, and so you see like J5 is minus 121 degrees. Okay, and so what I want to do now is in the program, I'm going to create a loop. Okay, and I'm going to say while I need a label. Okay, so I need to insert a label. And I want to jump back to point 1. Remember, labels are unique in each program. Okay, so label 1 is unique here. And then for the what I'm going to do is I'm going to adjust. For right now, I'm just going to adjust position 5. So I'm going to come here to instruction, and I'm going to say if, or I'm going to say if, actually, I don't think it's going to let me do this. Okay, yeah, so what I'm going to have to do is actually create a, I'm going to get the Z position, or the joint position 5. Okay, so I'm going to take this and I'm going to store in register. So this needs to be register. I mean, it doesn't have to be register 5. You can use any register as long as you're not using them for something else. And I'm going to say that at is equal to 0.5 of position register 7. Okay, so or joint 5, whatever the angle of joint 5 is. Okay, so right now, joint 5 is minus 121.030. Okay, so that's what this is going to start off at. Okay, so this is going to say, okay, we're at 0.5 of, so R5 is this angle. And then what I'm going to do is I'm going to use an if statement. I'm going to say, well, if the angle is negative, okay, I'm going to add to it. Okay, so if the joint is negative, I'm going to add to it. So I'm going to say instruction if, and I really kind of recommend maybe that you make a macro for this. Okay, although I didn't state it in the lab, but if you do, make sure you include your macro in the lab. But I'm just going to do this one value right now. So I'm going to say if R5 is less than 0, which means it's negative, then I'm going to jump to label 5. Okay, it could be label 2, but I'm just going to make it label 5. All right, so I'm going to jump here to label 5. And what label 5 is going to do, so I need to insert a label 5. Okay, and actually, I'm going to insert a jump here first. I'm going to jump to label 8. The numbers don't matter that much. Just keep track of what you're doing. But I'm just kind of jumping on label 8 here. And then I'm going to insert label 5 now. And label 5 is going to add, I'm going to add 30 degrees. In the lab, I tell you to do it by 5 degrees, but I'm going to add 30. So hopefully you'll see why I said to do 5. So what I'm going to do here is register 5. Okay. I'm going to take register 5 and I'm going to add to it 30 degrees. Remember, these are angles, so everything's in degrees. Okay. And then I'm going to stick that back into my position register number 7. Okay. So I'm going to go back to instruction, registers, and I'm going to do an equal to, but I'm going to choose the PR. So I'm going to say number 7, 5 is equal to register number 5. Okay. And then I'm going to move this by 30 degrees. Okay. And so we're going to move this by 30 degrees. So I need a motion instruction. Okay. And I'm going to leave it in joint. but this is going to be position register. Position register number 7. And I'm going to slow it down here a little bit, or a lot even. I'm going to make it run at 10%. Okay. All right. So now when I do this, then I'm going to jump back. I'm going to jump to label. I need a label 8 here. Instruction. Actually, I should have the label 8. Yeah, the label 8 needs to be in front of this. So I need to insert a line. Okay, and then I'm going to have my label 8. Label 8. And the reason I have label 8, let me just label that for you now. So this is skipping the if statement. Okay, so the reason I put that there is I'm only need to add to it if it's negative. If it's positive, I shouldn't be adding to it. Actually, I should be subtracting it. Okay, so I'll demonstrate that. So let me just label this first. So okay, so what I'm doing here is if the joint was positive, I don't want to be adding 30 degrees. I might want to be subtracting if it's positive because I want it to go to 0. So that's why I've kind of got this skip in here. So we're going to skip over that if it is positive. Okay. And so then as I run this now, I need one more instruction. I need to jump back here to this label. I need to jump back up here to the label 1 and repeat this. Okay. So now let me add to the display. I'm going to go to a double display, and over here on the double display, I'm going to go to data and look at my position or my data registers. Okay. So remember, we're modifying data register number 5, which right now is 0. Okay. So what I'm going to do is I'm going to walk through this program and show you what happens. Okay. Now, the other thing, let me zoom in on this. We're only moving joint 5. So I'm just going to zoom in way in on joint 5. And we want to set joint 5 to 0. So watch what happens with the program here. I'm going to step through this. Okay, and notice here that register 5 is now a negative 121, right? Because that's what my current position is, right? My current position is minus 121 at joint 5. And so when we look at the code, right, line 3 took the current position, took joint 5 out of the current position and stored it in the register. Now I'm going to go through the if statement. If R5 is less than 0, we're going to jump down here and add 30 degrees. So as soon as I add 30 degrees, it's at 121. So it's going to be at, we're going to add 30 to that. So it'll be at 91. And now it's 91. Okay, so now I'm going to run through that and it should be moving. Why is it not? Now we should be moving R5 is 90 minus 91. And there it moves. I don't know what the thing was doing. So now it's moving 30 degrees. Okay, so now my new position is minus 91. And then when I run this again, R5 goes to 61. I see what it's doing. It's sort of following the mouse. I never noticed that before when I move the mouse over there. All right, so but when I move, it's going to take here, it's going to take R5 back and shove that back into joint 5 location of the position register, and then it's going to move it wow. I don't know, my mouse seems to be going crazy here on me. All right, so when I hit forward, it's going to move it another 30 degrees. And when I do it again, it's going to move it another 30 degrees. Okay. Now it's at minus 31. I do it one more time. It should be at minus 1. Okay, and it's going to move it. All right, but now watch what's going to happen now. If I hit this one more time, it's a negative 1 now. If I add 30 to it, it's now positive 29. Okay, so it's now a positive 29, and so now it's actually going too far. Okay, so what you have to do is you have to, once you get it close, then, if you go too far, then you're going to have to move it back, and you got to make smaller adjustments. Okay, so I'm doing like the huge 30 adjustment, but as you get closer and closer, you need to change your adjustment so that you're only adjusting by, 5 degrees, then 1 degree, and then 0.1 degree, and then 0.01 degree, so that you get closer and closer and closer until you're at 0. All right. So let me just, let's see, am I in joint mode? Yeah. So let me, so now notice here that it's actually at a positive 21 degrees, right? If we look at the position, or 29 degrees, 28.9. So round up and we call it 29. So J5 is at a positive 28.97 degrees. And so if I run this program now, watch what happens, right? It gets to line 5, so we're at line 5. I gotta watch my mouse keeps moving on me here. At line 5, and then I hit it, and it jumps down here to line 9, so it doesn't add another 30, because otherwise it would just, end up going bigger and bigger and bigger. So that's why I added that label 8 to jump over that. Okay, so since we're now positive, we're jumping over the part that adds if we're negative. Okay, but what you have to do, and again, this is your homework assignment, you also have to add the other piece. So that now that it's a positive 28, then you need to move it back, because it should be at 0. So I want them all to be 0. And then what you'll have to do is you'll have to say, well, if it's, if it's at 30, now I'm going to have to change it and only move it by 5. Okay, or 4 or 3. Well, I would do, like, I think my lab said to start at 5 degrees. So I'm actually going to move by 5 degrees. So let me, I'm going to jog this back to a negative number. Okay, so I'm going to jog this back negative. And then I'm just going to run it through the loop again. I'm going to take step off, but watch R5 as I run this. Okay, so if you sit here now and watch, I'm going to take step off, and I'm going to run this program. And you see R5 there changing. It's dropping down by 5 degrees every time. And now once it gets down to -4, and then it goes to a +1. All right, and then you can see it's kind of sitting there flipping back and forth because it's skipping over those lines. Okay, so this is probably going to be a bit of a challenge for you. Why am I doing it in small steps, Robert? Well, the reason I'm doing such small steps is because if you try to make too big of a change and it changes that configuration piece, remember the configuration? When it tries to change configuration, this, like right now you see it says FUT. Remember, it can say FUT or NUT or NUB or NDB. This configuration piece up here at the top, when you're trying to go between like not flipped and flipped, or up and down, or front, the T is front and back. When you're trying to change that configuration, it won't let you do a huge 30-degree change. Okay, it will not go that far, and that's why I said like make it like 5 degrees. Okay, and do it in small increments. All right. Because if you just like said, hey, let's just do it, it's going to give you some kind of the error you will get is a configuration error. And I don't see the software doesn't pop that error up very often, but I see it on the actual robots all the time. If you're trying to go from point A to point B and they're totally two completely different configurations, it just squawks at you and it throws out a configuration error. And so by doing these small steps, you kind of walk it through the configuration change and it'll do it. But if you just try to do it from point A to point B and make a huge configuration change, it'll pop out that error. So you need to take them in small baby steps, as they say. All right, so there's your lab. If you looked, I set the due date to be next Wednesday instead of Monday, because I'm kind of thinking it might take you guys a little while to do this. So let's just kind of look at the calendar here. All right, wow, today's April 15th. Hopefully everybody got their taxes done. Anyhow, so the April 15th, and so this lab is due next Wednesday, is the official due date. If it takes you an extra couple days to get it done, that's okay, but it's gonna, this probably gonna be a little bit challenging because you gotta figure out some logic here. I mean, we're only adding and subtracting angles. But you need to think about it a little bit. You may have to like divide because, when you go from like 5 degrees down to 1 degree, down to 0.1 degree, down to 0.01 degree, you could do it a couple of different ways, but one way would be to do like a division or something. So you need to kind of think about how you're going to implement this. So it may take you a couple of false starts to get this working. So like I say, if it takes a couple extra days for you to get it done, that's fine. But next week basically is lab. Okay, so you need to come in and do the lab. or I mean, you don't necessarily have to log in, but I'll log in at 12 o'clock. So if you guys want to log in just to kind of indicate that you're here, especially those of you who maybe have, I have to kind of report um, whether you're attending class, online and all that. So, I'll be there on each Monday and Wednesday at noon, and just log into the Blackboard here, and plus, if you have any questions, I'll try to stay logged on for a little while for that. But and then after that, the week of the 27th, that's going to be the exam week. Remember, it's going to be exam 3, which is just going to be a makeup exam. And then the following week officially is finals week, which I don't really have a final exam for this class. I mean, if you really want a second makeup, I guess I could give you that opportunity if you want on finals week. But but I wasn't really planning on it. But and then that's it. That's the end of the class. So we're coming down to the end here. Normally, if we were actually in class at school, right, you would be doing your project now, and then on finals week you would be presenting your final project. But basically this lab here is your final project piece. So, but then, like I say, so next week we'll have that third exam. I'll make that available, and then the following week, I guess I'll make another makeup exam available if you want to log in and do that. And I'll just take the highest 2 exams out of the 4, okay, as far as the grade, if that sounds okay. So any questions, comment, any of that? All right, so so that's the lab. Go ahead and get started on it. I'll stop this recording here, and once it's done, I'll post it so you can come back through and watch it again.